Hello, my name is Timur. First of all, I want to apologize. I'm going to do the talk in English and not in Russian. I hope it's okay for everyone. I do speak some Russian, so you can, after the talk, you can ask me questions in Russian. I'm probably going to be able to understand you. But unfortunately, my Russian is not good enough to give a talk, so that's going to be in English. I hope that's fine for everyone. If you don't understand me, please interrupt. Everyone okay? Okay, so I work at Rolly, which is a company in London, and we are doing music, software, and hardware for playing music and music technology. And we also do Juice, which is a framework, C++ cross-platform framework for writing applications on desktop and mobile. And we also organize the ADC, which is the Audio Developer Conference. It's a yearly conference of the audio music software community. I'm really happy and excited to be here, so thanks Nastya and JetBrains for inviting me here and for hosting this event. I think they're doing great work for the C++ community, and they have some great products as well, so really appreciate it. Thank you very much. Okay, normally I give talks about things like lock-free programming or low latency, performance, C++ things, or audio-specific topics. But today I want to do something a little bit different. And it all started at CPPCon last year, where I gave this 5-minute lightning talk about Readable C++. It was more or less a spontaneous thing that I prepared the same day. It was basically a 5-minute rant about how I think that C++ code tends to be really ugly and unreadable. And it was a fun talk. But afterwards, I was looking at the comments on YouTube, and I saw this. So first I thought, so the guy's writing, I was hoping you would talk about how to actually write readable C++ instead of just ranting. And first I thought, okay, how was I supposed to do that in 5 minutes? And then I thought, thanks guys, actually ways to write readable C++. That sounds like a great topic for a talk. So today is going to be my first shot at this topic. I'm going to start with a little bit of material from that lightning talk, and then I'm going to move on with some new material. So instead of a 5-minute rant, today I'm going to do a 1-hour rant. And I hope this is going to be entertaining and perhaps interesting to some of you. Right. So let's start in the beginning. The first time I got into programming was about 10 years ago. I was doing astrophysics at the time, and we were doing numerical simulations of cosmological structure formation. They look like this. So this is a rendering from one of those computer simulations. They run on massively parallel clusters of high-performance computers. And we were using these things to study how galaxies evolve in the universe. So that's pretty cool, huh? Let me show you the code. So that's some of the actual code that was running there. Do you know what language that is? Fortran, yeah. Okay, so that's the beginning of the simulation code. Let me scroll down a little bit. Yeah, it continues like that. There's some nested loops in there. It keeps going, some more declarations. Yeah, it keeps going and going. Some more declarations, some more computations, some interesting variable names in there. It just keeps going and going and going. It's like thousands of code like this, and this is how I learned how to code. This was my first programming language, and after a few years of this, I was like, is that really it? Is that how you write code? Is that everything? No, there must be something else. This is not a nice way to write code. And I started to look around, and then I found C++. And I thought that's much nicer. And then I went to my supervisor at the time, and I said, hey, that new project that I'm supposed to write, I'm going to write it in C++. And he was like, are you crazy? No one's going to be able to read your code. But I did it anyway. It was fun, and I learned some C++. And then I decided, hey, that science stuff? Actually, C++ is more interesting. Maybe I should just become a C++ developer. So I quit the science stuff, and I applied for my first job as a C++ developer at a company called Native Instruments. They do music, software, and hardware in Berlin, in Germany. And they gave me this kind of homework coding test as part of the application, which was something like this. yeah, you have a string, and basically you need to search and replace one substring with another substring. And I was like, hey, that's easy, right? Okay, let's look at Stack Overflow. Okay, that's the first answer. Why not implement your own replace? Okay. Next answer, well, you can do it like that. I especially like the second one. It says, if you need performance, you can do it like this. The next guy writes, I believe this would work. It takes a const char pointer instead of a string. That's also very nice. Now in C++11, you can do it with regex. So that's really cool. And also you can write a templatized version. So yeah, I was staring at all this stuff, and again, I was like, is that it? And then I was again searching, and then I found Juice, which is a framework that has a string class. And in Juice, I could just write it like that. String.replace. And that's the code that I submitted for the job interview. And the people there were like, hey, this guy knows Juice. And I got the job. So yeah, that was cool. A few years later, I moved on. I'm actually working now on Juice. So that's something that I like. And I learned a lot during that time. I want to point out a particular book that I read. It's this one. Anyone here has read that book? Can you raise your arm if you read that book? Okay. You should really read that book. I think every developer should read that book. And for those of you who have not read that book, let me summarize the book in one slide. The only valid measurement of code quality is WTFs per minute. And I think that's really, really true. I think good code should be readable. In fact, I think it should be as close as possible to plain English. And that's something that Juice is really good at. Actually, from what I hear from our users, that's the #1 reason why people like writing code in Juice, because you end up with code like this. It's just a simple example, but it's just code that naturally looks a lot like English, and it just tells you immediately what it does. So you can write code like this, and I think this is good code. Let me give you another example. So in C++, if you have a vector of items and you wanna remove all the non-valid items, this is the way to do it. Yeah, it's called the erase remove idiom. I'm sure most of you have seen it, and I think it's ugly. Actually, it's so ugly I don't even know how to indent it properly. It's really confusing because std remove doesn't actually remove anything. It just shuffles some elements to the end. It's not a really easy thing to remember. And then there's the whole issue about algorithmic complexity. If you write it like this, it's linear. If you don't write it like this, then it's probably going to be not linear. And it contains a lot of stuff that has nothing to do with what you're trying to do. Like all the red stuff here, it's just boilerplate, right? If you just look at the stuff in between, that's what you want to write. Items remove if the item is not valid, right? That's the code. And the rest is just boilerplate. And I don't want to have to write that. Again, in Juice, you can write it a little bit shorter, like this. You still have this boilerplate because of you have to write a lambda to do this. And this is still better, I think. And this is some kind of this is the kind of stuff that I want to be able to write in standard C++ as well. And I think we're going to get there. There's ranges which are coming in C++, so we don't have to write begin and end anymore at some point in the future. And then there's, I think, also a proposal to wrap the erase remove idiom in one function. So we're going to get there eventually. But C++ standardization is a very slow process. So, working towards more readability there takes years. But I think we can do it in our own frameworks and in our own apps and influence the way we write code there, which is something that we can actually do. And the reason why I think it's important is I don't remember where this quote is from, but I like this quote a lot. High-level languages like C++ are usually not written to communicate with compilers. They're usually written to communicate with people. I think that's very true. If you think about it, a typical developer, in a typical company, spends only about 20% of their time working on his or her own code, and about 80% of the time looking at other people's code. Now, you're trying to find a bug, trying to understand an algorithm, the architecture. You try to find a place where to fit your new code. That's a common problem with legacy code. And over the lifetime of the application, I think at least 80% and often more than 90% of the time goes into maintenance. The money doesn't go into writing the app, it's going into maintaining it. And also in many companies, people come and go. And also, to be honest, not all the developers are rockstar developers who know all the C++ features and can read everything that everyone's doing. So for all of these reasons, I think it's really important to keep the code base readable by all the people in your team. And here's my motivation why I want to talk about this today. So at Rolly, we recently released Blocks, which is this product here. So we have a mobile app that runs on the phone. Then we have a hardware device, which you see below the phone, which is called the LightPad block, and has a sensitive touch surface and has LEDs. It has an embedded system on it. There's some code running on the hardware device. They talk via Bluetooth to the phone. And they also have little magnets on the side, so you can snap many of them together. And they'll talk to each other on an embedded mesh networking algorithm. And also we've built a custom IDE that I think we will release soon, where you can sort of hack those devices and write in a custom scripting language, and then the devices are going to run your code. So anyway, the point is, it was a huge project. It was a big team, and many of the components we have written from scratch. And you think this is a developer's dream, just writing lots of code from scratch using modern C++. What can be better than this? And actually, I have to say the code readability in that project ended up to be quite good. Not compared also to other projects that I was involved in the past. So I think we mostly did a good job. Not perfect. I mean, I'll show you some code snippets later, but good. I wrote a lot of code for this project myself, and I did a lot of code reviews for that project. And it was basically the past year or so. And this year for me was a good reminder of the practices that I think are most useful to get this kind of readability. And now that this project is sort of over, I think it's a good time to reflect and to sort of think about those things. And I want to share some of this stuff today. So the first thing that we had, which was great, is we were using Juice, which is a framework that has been around for a while. It's been written originally by Jules Storer. He's the founder of Juice. And he had some very good coding standards that we adopted. And that's really great. We have those coding standards online. And several companies have that. Google has their coding standards online as well. I think that's a great thing. Can I get a show of hands who works in a place that doesn't have official mandatory coding guidelines? You should get them today. It's going to save you a lot of money. And this is stuff like white spaces, camel case, indentation, a lot of like C++ 98 stuff, like how to write like constructors and when to throw exceptions and this kind of stuff. And I'm not going to talk about this. I'm going to talk about like a thin layer on top of this, which I think, and I'm also not going to talk about design patterns or any kind of higher level architecture, because I think it's a big topic and it really depends on your domain. I'm going to talk about much simpler things that are relevant, I think, everywhere, whether you're writing a desktop app or a framework or Boost library, whatever it is, or embedded stuff. It's basically naming, commenting, redundancy, repetition, and scope. And then I'm going to talk about a few C++ 11 features and C++ 14 features and how they fit into those principles. And then maybe a little bit of C++ 17 stuff if there's time in the end. So let me start with the thing that I think is most important, which is naming. So here's a good name and a bad name. So I think the yellow-tailed woolly monkey has a great name because it's a monkey, it's woolly, and the difference between this species of woolly monkey and other species of woolly monkey is that it has this yellow fur in its tail. So I think that's a great name. And the guinea pig, I think it's a shorter name, it's more catchy, it's more popular. But I don't think it's a good name because it's neither a pig nor does it come from Guinea. So it's not a good name. I think names should tell you why it's there, what it does, how to use it. They should reveal the intent of the thing. And the other thing is I think names should be whole pronounceable English words. So maybe if you know the game of Scrabble, if something's not a valid Scrabble word, it's probably not a good word for a variable name or a method name or a class name. You know, a lot of people I've seen doing things like that, and I used to do that a lot as well myself, where you have some short variable name and then you explain in the comment what it is. And I don't think it's good because the comment is there only where you declare it, but then everywhere else you just see this name which doesn't tell you anything. Sorry? Mm-hmm. So yeah, you should really, if you explaining in the code what this variable does, then you should just put it in the variable name. My opinion. And I think you should also not use abbreviations in variable names. Let me show you an example why this is bad. So as I said, we have these blocks, which are these devices on the bottom, and it's a grid with, like, one of the things it can do is show this grid with rows and columns, and you can use it to play music. And you see that the squares have different colors, and maybe you can see that the colors are generated from a color gradient. Now, this is the function that draws the grid, or, well, the way the function originally was written before I refactored it. And that's a lot of code. And here you see those two variables. And when I saw this, I was genuinely confused because you see blend col and blend amt. And col, okay, is that color or column? And the problem is in this function, it could be both, like both are actually meaningful. And amt was also another problem because my native language is German. And in German, amt means something like department or office, and it's a very, very common word. So I was so distracted by this word that I couldn't figure out what the person actually meant. And then I had to actually stare at the code around it, to get it from the context, which is just much slower, right? And maybe you're not interested in the implementation of this thing. And then it turned out that, well, actually it's the color and the amount. Yeah, then I asked the person who wrote this, why did you call the variables like this? And he said, I wanted to be brief. And I think that's a very interesting insight in developers' psychology. I think you can explain almost everything with psychology. You need to know that this code runs on this hardware device, right? It's an embedded system. It has a tiny chip. It has something like 16K of memory. So the binary size has to be really, really small. That's really important. But that doesn't mean that somehow the variable names need to be short too, right? But your brain just makes this association. But when you write variable names, you're not talking to the compiler because the compiler is going to throw them away. You're talking to people. So, right. Obviously, there's an exception to the whole word rule if you have a counter variable or maybe a quantity from a mathematical function. Then you would probably use letters. But then even then I would keep them pronounceable. I, phi, n, that's something you can pronounce really easily. So these are good names, they're nice. And some people like use this kind of stuff, where they have variables like axpv2, which you can't really pronounce. And I think unless everyone in your team knows exactly what axpv2 means, I think that's not a good variable name. SQRT is okay because everyone knows what that means, right? But with this one, I would think, like, how would you explain the meaning of that symbol to someone speaking English? And let's say it's the expansion factor squared. I don't know, I just made that up. But, so maybe that's what you should use for the name. The other thing about name is that I think they should be consistent. So one thing that really annoys me actually in Juice is that we have this inconsistency in there. We have this graphics object which paints different shapes, and then one method is called fillRect and the other one is called fillRounded rectangle. So there's this kind of inconsistency whether you call a rectangle a rect or a rectangle. So you can't really rely on finding another method that does something with a rectangle because it's inconsistent. And I think it should be consistent. I think it should be fillRectangle. And I really hope we can make this change in the framework without breaking too many people's code. I think names should avoid disinformation. If you have a vector of accounts, you shouldn't call it account list because usually a list is something else. When people see list, usually they think about a linked list or something like that. So I think something like that is confusing. So I would just call it accounts. Names should be sufficiently different. Like sometimes people end up with those really, really long names, which are maybe a little bit too long, and then it's really hard to actually spot the difference, which is somewhere in the middle. So I think names should be really obvious to search for. Let's say, so this is a screenshot from our mobile app. And let's say someone asks you, hey, could you make this restore all button just a little bit bigger so it looks a bit nicer? And the app maybe has 100,000 lines of code, and you have no idea where this button is. You haven't written it, right? So what you do is you hit Command-Shift-F or whatever it is in your IDE that searches the whole project, and then you're going to type something in there to find that button. And that button better should have the name that you're going to type. And in this case, it's probably going to be Restore All button. So that's the name that this button should have. And if the person changed the text from Restore All to Redeem All and didn't change the actual name of the object in the code, you're not going to find that button. You're going to find that button a couple of minutes later, which is not a good thing. So yeah, obvious names. Functions. Functions should be, I think, verb phrases, things that start with a verb. So shutdown, remove listener, get with, those are great names for functions. There's a few other things here, like, for example, if a function has possibly does a lot of expensive stuff, like, for example, if I see a function like get with, what I expect is that this function is going to be const, and it's going to just return you a value, it's not going to do anything. And if it's not like that, you should make it clear in the name. Like, if it actually has to do some work before it gets you something, it should probably not be called get, it should be called generate or compute, like generate histogram, which is going to actually compute the histogram and then return it. So you can express all this information in names. And another thing is if a function has side effects. I'm sure some of you are, and myself as well, are fans of functional programming where functions don't have side effects. That's great. But unfortunately, in reality, sometimes they do have side effects. And then you can make that clear in the name. For example, if you have a function that gets an account, but then if the account is not there, it's going to create that account. That's a side effect. So you can express that in the name by saying that the method name should be not get account, but get or create account. And that's, so the function tells you, hey, I'm actually possibly doing some extra work and I'm possibly affecting something else. So you can be really expressive with names. Bools, I think, are essentially yes-no questions. Like this game, yes, no, you ask questions and you can answer with yes or no. And I think bools are like that, whether they're variables or whether they're functions returning a bool. So the names for them should be yes and no questions. Is it active? Does it have a file extension? Should be visible? Can respond to notifications? So they tend to be beginning with things like is, has, should, can, use. And I think this is good. There is an edge case where the STL is saying that it's not is empty, it's just empty. So in Juice, all the containers have methods that are called isEmpty, and which I like. But then, which one do you choose? And I think it really depends on what you're doing. Like, for example, if you're writing a Boost library, probably you're going to go with this because it's closer to the STL and the C++ standard. If you're writing an app, you have your own framework, probably you're going to go for the more readable one. So, it's not always black and white, but this is more about like the direction. Classes should be nouns. I saw once a talk by Tony van Aert, great guy, gives great talks, and he said, basically, if you can't pick a noun, if you have a class, you don't know how to name it, you can't pick a noun straight away, then what you should do is you should describe your class to someone else in one sentence, and the word that you're looking for is going to be somewhere in that sentence. And I would add to that the sentence should be smaller than 25 words, and it should not use the words if, and, or but. And if you can't make a sentence like that, then probably your class is doing too much and it's too big and you should redesign it. There's a few words also that are really dangerous. If you end up using them in class names like manager, processor, data, info, they're very generic, and either they're not going to tell you what the class is really doing, or they again mean that your class is doing too much. And then if your class is doing too much, then you end up with those classes that I call baobab classes, like the baobab trees in The Little Prince. It's like they grow, and then they eat the planet completely. And I think almost every software project I ever was working in had one or two of those Baobab classes, and I'm sure I've written one myself as well at some point. And they're really dangerous because they tend to contain all the bugs, and also they keep growing because people don't know where to stick their code, so they just stick it in there because that's where everything else is. So they keep growing and growing, and then people think, well, as soon as their code is working, they're done. So Baobab classes can be very expensive, and yeah, I think you can write a huge project where most classes are not bigger than maybe 4 or 5 member variables and maybe a couple hundred lines of code. I think that's really possible. Okay, one more thing about names. I think it's a good idea to use established terminology. You know, if you use patterns that people are familiar with, like the pimple or listener, visitor, you know, that's an obvious name for your class. Everyone's instantly going to know what you're doing. However, you need to make sure that the people on your team are actually familiar with the pattern. Let me give you a counterexample. In the app that we have, one person at some point who was architecturing part of the app wrote a class and named it dependency injection container. Now that person was had a background in C#, and in C#, you know, that's a thing, that's a pattern. You know what that is. But we had a team of C++ developers, and no one of us had any idea what a dependency injection container was. So it confused our team. It created a lot of confusion in the team, and then at some point it became this kind of joke. We're like, hey, where's the code that makes the app go from one page to the next? It's in the dependency injection container. And then at some point we decided that we have to end this. So, you know, the question was, okay, what is this class really doing? It is managing the lifetime of all the dependencies. So the name should be Dependency Lifetime Manager. And that's a hint that maybe there's something wrong with that class. Maybe we should refactor it. So I think names can tell you a lot. Okay, enough about names. Let's go move on to comments. And there's a great quote from the Clean Code book, where some of this stuff actually comes from. I think it's a great quote. I actually don't like comments very much. It says, every comment is a failure to express yourself in code. And I think that's really true. I think instead of comments, you should have good names and readable code. So we already had this example here where, you know, if you say, you know, this variable is doing that, instead of putting it in the comment, put it in the name. Another problem with comments is that, you know, don't state the obvious, you know. If you know, that's a simple function, it computes the mean of two numbers. You know, you don't have to, if you don't have to write the comment, don't write it because it's less stuff to read. If you do have to write that comment because it's not clear what the function is doing, you know, maybe you should rework the code to make it a bit more clear. Another thing about comments, so here's another snippet from the actual code that we use in the app. And sometimes comments are a hint that maybe your function is too long and you should wrap things. Like if you have a function, you end up sort of like writing comments to denote, you know, the different sections in the function. Like we're doing this first and then we're doing that. I think that's a strong hint that you should actually break the function up. And with the first one especially, I think if you have a condition, like a long condition, and you have to write a comment to explain what this condition does, maybe you should wrap this condition in a little function that returns a bool, and then this description should go in the name. And then if you do that, then the function ends up looking like that. And this is the kind of function that I really like. So the reader will instantly know what happens on a timer callback without all the implementation details. You can still access the implementation details if you're interested by looking into those sub-functions. You wrap the conditional, so you don't have to worry about that. And the result will often be code that looks like English. And I think also it's a good size for a function. I really try to keep my functions under 10 lines of code. I think that's sort of like the function size that, if you just look at it, that's sort of the limit of what you can immediately understand. If it's longer than that, you have to actually read through it, which is going to cost you some time. And I don't think any function has to be longer than that. There are a few exceptions. Sometimes I have a function that's 20 lines. And if I can't break it up, if it's really some complicated piece of logic, then at least I'm going to tuck it away somewhere so no one has to actually look at it, and I'm going to give it a good name. One more thing about comments, and that's really, I think, a pet hate of mine, because people keep doing this. That's another example from production code. Commented out code. Why did the person comment it out? Do they want to put it back in? I don't know. I mean, sometimes they put a comment saying, uncomment this code once we did this other thing. But it's not necessarily clear who's supposed to do that and when they're supposed to do it. And especially bad in this case because so probably when they commented this code out, then they got a compiler warning that's saying unused argument. So they removed the argument name. And now if you comment it back in, then it's not even going to compile. And I think either code belongs in an app or it doesn't. And if it doesn't, remove it. Make a git commit saying that you removed it. And this way, if you want to bring it back, it's going to be much easier to find because it's going to be in the git log. And it's going to be much easier to undo because you just run git revert. But sometimes comments are great. And let me give you an example about that. So in the Juice framework, we have a macro called jassert false. So we have another macro, jassert with a condition, and then just jassert false. And what this macro is doing, you put it somewhere where you know something went wrong. And what it's going to do, it's going to tell your IDE to break there, and it's going to throw you into that file, and then you can sort of debugger is going to break, and then you can, figure out what went wrong. And typically, if you encounter this in a Juice app, then it's going to be in some file that you have not written, that you have not even seen ever, probably. There's going to be like a long call stack with some stuff, and you don't know what's going on. You only know something went wrong, and then you have to figure it out. And we have one rule in Juice, which I think saved us a lot of time and money, is that if you ever write this kind of assert thing, you always write a comment above it explaining what's going on. And then instead of searching for what went wrong in that other person's code or in this framework code or whatever, there's always going to be a comment telling you, this is the thing that you did wrong, fix it like that. So I think that's a great thing. That's the thing that I found really, really helpful. Okay, so enough about comments. Less is more. I think a good way of writing readable code is to actually write less code, because it's going to be less to read, less to understand, less to reason about, and less bugs. And it starts with really, really, really small things, like this one. If you have a function like if-else, well, the else is not actually necessary, so I don't write that else, I just remove it. And actually, the way, by removing this else, I'm adding a little bit more information, because I'm saying, the first thing is probably some kind of special case, and then the last thing is like the default. So I think it's more expressive. Now, let's get a little bit into C++11 territory, because I think a lot of the features, like the newer language features, are aimed at writing less code, which I think is a great thing. So let's start with auto. Obviously, auto is great. Everyone likes auto. So here, for example, the first auto, you don't have to spell out the iterator type, which is going to be a really, really long type. You don't have to write that. It's great. The second one is a C++14 feature where it's called generic lambdas, where you don't have to write the argument type of the lambda, and it's going to deduce it like it deduces template arguments. It's the same way. So it's just going to figure out what that type is. So you don't have to spell that out. You don't have to write std vector iterator colon blah blah blah. So that's a great use of auto. Then sometimes people do this, where you have a function that returns some object, and you don't want to write that type, so you just write auto. And I think in this case it really depends, because if in the code around it, if you don't need to know the type, or if it's really obvious what that type is, then yeah, you should write auto, because it's going to make the code shorter. But sometimes the type is meaningful. The type is actually some information that helps you understanding the code, and then I think you should not write auto. And then I noticed some people started doing this thing, and I think this is something that we shouldn't be doing. I think it's better to write it the old-fashioned way, because in this case, auto is not shorter. Auto is not adding any information. Auto is actually removing information, because it makes it more difficult to read. It's much easier to read if you have int and double spelled out. And the other thing about this is someone said, Well, actually, auto is good because auto forces you to how do you call this? Define the value, right? So initialize the value. So if you write auto, you have to write equals something. You can't have an uninitialized variable. So you should use auto. And I think I don't agree with this because I think this only works if you have a rule that you should always use auto everywhere. And I think at that point, it's much better to have another rule, just always initialize your variables. So anyway, auto. Lambdas are also great. Lambdas are great if you have things like this, where you want to call something asynchronously, for example, in this case, and you give it any kind of function. You can use a lambda. You can capture this. You can call member functions in there. I hope this is not going to dangle at some point. You have to make sure that that doesn't happen, but otherwise it's really short. Lambdas work really well with STL algorithms like this one, where it's really obvious what you're doing. You're sorting the items by time. So you don't want the comparator to be somewhere else. You want everything to be local, so it's really easy to see. So that's a great use of lambdas, but I think this is just about the maximum size of lambda that's readable, and if lambdas get longer than that, I think I wouldn't use them, because if it's doing something more complicated than this, then maybe it's some custom logic that you're doing, and maybe at this point, it should have a name. If it's doing something more complicated than this, maybe it should have a name. And so my personal style would be to avoid multi-line lambdas and also to avoid nested lambdas, which people are also doing, unless it's really essential for what you're doing. Like if it's really important for what you're doing to have nested lambdas, fine, but otherwise I would avoid them because they tend to be unreadable. It starts to look like, I don't know, my brain can't parse this. So it's like extra seconds that I don't want to be spending understanding what the code is doing. And another problem with lambdas and STL algorithms that I see sometimes is code like this. So this is a snippet of code that's from our own IDE, where it's really cool actually. Like you can have live code running on the block, where you have some custom code to make the LEDs flash or whatever, and then you have like a custom IDE where you can have, for example, a slider for a variable, like a dynamic variable, and you can change the value of like a float with the slider, and then it's going to instantly change the value on the running device. So that's kind of live coding. That's pretty cool. Anyway, that's a snippet of code from there, and let's look at this code. Okay, cool. So this person is using STL algorithms. That's really great. Probably they have seen Sean Parent's talk about STL algorithms. It's called C++ seasoning. Has anyone seen that talk? I really think you should. It's my favorite C++ talk. Please check it out. It's great. It's from a guy called Sean Parent. It's called C++ seasoning. It's really great. Anyway, he says that you should not write loops. You should write STL algorithms. So it's one of the many things that he says. So this person wrote an STL algorithm to find a dynamic variable, and then there's a lambda with the criterion, like what you're looking for, and then findIF returns an iterator, so you have this iterator, and then you have to compare this iterator with end to figure out whether you got an item or not. So there's a lambda in there. It's capturing the string by value. I'm not sure that's a good idea, but anyway. So there's a lot of modern C++ in there, but the problem is that actually you can just write it in a simple loop, and that's going to be much more readable. In fact, you can write a range-based for loop, and then this whole code becomes much closer to English and much simpler, and you don't need the iterator, you don't need the lambda, you don't need any of the stuff. And then if you read that code, it's just telling you what's going on. It says, go through all the variables and metadata dynamic variables. And if you find a variable with a name equals name, then set the current value to new value and return. And that's almost like English. And this is, I think, is nice code. So basically, I think we should do whatever we need to do to make the actual code as short and readable as possible, so you can read it. And it doesn't actually matter what C++ features you use in there, and as long as you reach the goal of having clean code. Just a few things that I want to mention. A few more things that I want to mention here is flag arguments. some people do this kind of thing. I really don't like it because it's an instant WTF per minute. If you want to understand what this does, you always have to look up the function. So it's always an extra click, right? So in this case, it turns out, okay, the first bool is whether it should own its content. The second bool is whether it should intercept mouse clicks. And the third bool is whether it should be resizable. Well, okay, so the first one is actually needed in this case for the content, but then the others are not really that much related, so we can put them in extra functions. And if we use that, we can write it like that. That's a bit more code, but I think with this code, you don't have to look up anything. It just tells you what's going on. Whereas with the other one, you don't know what's going on. I don't really like pair and tuple because I actually don't use them. Because if you look at a pair, a type like this, pair of a string and an int, it doesn't tell you what the string and the int does. It doesn't tell you what it means. And if you use them, then it's the same. Like you would refer to the string as first and to the int as second, and it doesn't tell you what the meaning of these things is. So I try to avoid this thing, and I try to just make a custom struct with member names that tell you what these strings and ints actually mean. It's probably going to compile down to the same thing anyway, but it's much more expressive. And the same with tuple. And I think parent tuple have this tendency to just lead to unreadable code because there's also a lot of other features around them to make them do stuff, which you don't really need if you just write your own struct. If people have classes with a lot of members in them, sometimes you align them vertically like this. I'm never doing that. I always leave like one white space character between the type and the variable name, because I think if you're doing this, sort of like the eye is misguided. You tend to like read like vertically down the names rather than associating the name with the type. And I think if you have to do this kind of alignment, your problem is not that your formatting is bad. Your problem is you have too many members in your class. So maybe you should redesign that class. Magic numbers. That's something I always flag if I see it in code reviews. Reserve 4K of memory. Okay, why 4K? Why not 8K? Some people write a comment. Again, if you have to write a comment, it's better to express yourself in code. Some people introduce a macro. I don't think macro is code. I think macro is like a weird text replacement thing tacked on top of C++, and I try to avoid it whenever I can. But in C++11, we have constexpr, which achieves exactly the same thing, except that the name and the type of the thing is visible to the compiler, so it can do some checks for you, so it's much better. A few more general concerns about readability. I try to minimize the scrolling for whoever's going to read that code. Like files, I think, should typically be around like maybe 200 lines or maybe not more than 500 lines, because if they're more than that, then that's sort of the limit where you can navigate inside the file and you can remember where you are. If you have a file that's 5,000 lines long, you lose yourself in that file. If you write a class, I think I like this newspaper approach, where the most important thing is at the top, maybe the default constructor, and then the less important stuff is at the bottom. And for example, if you have a constructor and then you use 3 functions in there, then those should be the next 3 functions that are defined further down. So you have this kind of top-down story that you read. And if you have member functions in the header file and then member functions defined in a header declared in a header file and defined in a source file, then the order of these should be the same. So if you're in the source file, you can find them more easily. And another thing is, if you write code, like, does the person who's going to read it have to look up some stuff in some files that are hard to find? And that's especially true with macros. I found that some IDEs have problems. Like if you click on a macro, they have problems finding the definition. Like, for example, sometimes I have this problem with Xcode that it's just not going to, because you have this weird includes and probably it's not part of the project. It's somewhere in the system header. So, you're not going to find the macro, so you have to search for the macro manually, and that's going to take time. Okay, and then duplication. So someone said duplication is the source of all evil in software. I think that's great. That's really true, and I think actually most things, starting with like subroutines in the 60s or whenever it was, Most things were invented to get rid of duplication in the code. And there's always a way to get rid of duplication. You know, if you see the same chunk of code twice, wrap it in a function. If you see the same switch case statement twice, you can replace it maybe with polymorphism or whatever fits your architecture. In any case, your code is going to express your intent better and will probably be more readable. And actually, a lot of modern C++ features in C++11 and 14 are aimed to reduce this kind of repetition. For example, brace initializers. So David Rowland gave a great talk about brace initializers at the JUICE Summit 2015. It's some real great real-world examples. And I really recommend you check this talk out. It's on YouTube. So I'm just going to quickly mention sort of the basics. I think it's a really great features for readability. In this case, you can use them if you if you call a function, and then in this case we have this point struct and we have the triangle, and the constructor of the triangle takes 3 points. So in C++98 you would have to repeat the types. And since C++11, you can actually get rid of those and just write it with brace initializers, which I think is great. But again, we need to be careful about this. It needs to be obvious what's going on. Like in this case, I think it is obvious because a triangle consists of 3 points, right? So, and the point has like an x and a y coordinate. So probably, these are going to be the 3 points of the triangle. So that's obvious. But again, if it's not obvious, then probably we should not use brace initializers. So it really depends on the case. And the same for passing arguments. You can do the same with return types. If you have a function that returns a triangle float, we know what the return type is. It's the first thing in the function signature. So we don't need to repeat that type everywhere. We can just use brace initializers there as well. Another thing are default member initializers. Let me mention this as well. So especially for framework like JUICE, you have a lot of classes like this where you have maybe several constructors, right? You have a default constructor that's initializing something to some values, and you have another constructor where you can pass some values. Maybe you have a third and a fourth if it's a complicated class. And then you end up writing those initializer lists. And then, since C++11, you can actually put them in a default member initializers. And a few years of having these in the language and working with them, I found that it's a universally good idea to use them. It's especially if you have classes with many constructors, because it makes sure that no matter what you do in the initializer lists of all these constructors, your members are always initialized to something meaningful. So even if you forget to initialize a variable in the initializer list of a constructor, then it's going to be initialized to the default, which is 0 in this case. So it adds a lot of safety, and it also always makes the code shorter, which is good. There's one quirk of this which I want to point out that might be relevant depending on what compiler you're using. So let's rewind to C++98. So if you have a struct like this, it's really simple. It just contains of 2 numbers. And as long as the struct doesn't have, or class doesn't have any private or protected members, no base classes, and no custom constructors, you can just use these braces, and it's just going to initialize the members like this. So that's the feature that has been there since C. Now, of course, if you use the second version, the default constructor, then the x and y are going to be initialized to garbage, right? So you want to avoid that. So you want to write, in C++11, you want to write these default member initializers. Unfortunately, in C++11, this code is not going to compile, because you're going to get this nasty error, no matching constructor for initialization, which basically means that as soon as you have these default member initializers, it's not going to allow the aggregate initialization anymore. And then you have again to write a custom constructor like we did in the previous example. But fortunately, in C++14, they fixed it. So now you can use default member initializers, and you can still have the aggregate initialization. No, it doesn't matter.
Without an equal sign, it would not compile on C and all C++.
Well, that's only going to compile on C++14. This is not going to compile on anything lower than C++14, but in C++14 you can write it like this. Yeah, and you can also write the equal sign if you prefer that. That's a matter of your style or what your coding standards say, I guess. Yeah, well, as I said, like this really depends on what version of the compiler you're on and what version of the language you're on. Another little detail about those default member initializers that maybe not everyone is aware of is that you can actually call functions in there, and that's really great. So this is another example that I got from Dave's talk. Let's say for some reason you need to have a unique identifier for every one of your points, and then what you can do is you can just stick it in the default member initializer, and then if you have multiple constructors and then you forget to initialize that ID there, again, it's going to happen always by default. So it's adding this kind of extra safety, and it's flexible because you can actually call functions in there.
What I wonder, so is going to happen before or after, let's say we had a constructor there. So will this be called before or after that custom constructor?
So
If I have
yeah. So if you have an initializer list, I think it's going to do first the initializer list, and then it's going to do the default member initializations for everything that you didn't initialize in the initializer list. But I'm not 100% sure. Let's look it up afterwards.
doesn't the function need to be constexpr?
No, absolutely not. It doesn't have to be constexpr. Okay. Minimizing scope is also a thing that I think is important. So, in C++, since C++11, you can initialize a vector like with these braces, which is nice. You can also use a C array in this case. It doesn't matter. The example is about what if you just want to print out the first 6 prime numbers for whatever reason. And we can do it like this. But the problem with this code is that this vector is going to leak out into so it's going to be still there after the for loop. So it's going to be in the outer scope. But really, you just want this thing to live inside the for loop because you're only going to use it there. So what you can do is, instead of doing this, you can simply do it like that. And you don't need any vector or array or anything. You're just going to directly use this initializer list. And then there's no object that has any kind of scope, and it's much more compact. Another thing where this scope matters is, for example, some people do this kind of thing where, I think you see this kind of pattern often where you get a pointer and then you check if it's null, and then if it's not null, you do references and doing something with it. And but then again, this problem is that you only need it inside the if, but the pointer is still going to be around in the outer scope. So to prevent that, you can put the initialization inside the if, which I think is good practice. Now, in C++17, in the upcoming standard, this is going to be a bit more flexible, where you can define any kind of variable inside this if. So here's an example. Sorry? Yes? That one?
Yeah, shouldn't it be a widget dot render? I mean, I guess you're trying to make a reference, not a point.
Oh, sorry. One thing, I forgot the parent. So it should be render parent. It should be a function call. Yeah, I forgot the parenthesis. But
No, I'm thinking maybe instead of pointer, you actually auto is actually a reference. So maybe it's widget dot render.
no, I wrote auto star. It's a pointer.
Oh, it's still a pointer. Oh.
Yeah, it's still a pointer. Oh, it's still a pointer. Yeah. No, the mistake here is that it should be widget render, and then it's a method call.
You also can do that if you have more than one pointer. So it only works, I remember, for only one.
Yes, this works for only one pointer, but then it's going to be much better in C++17.
But you may use nested ifs with all pointers like this.
Okay, let me show you what you can do, what you will be able to do in C++17. So here's another example where, so instead of checking a pointer, here we're inserting something into a std map, and then map insert has this interface where it returns a std pair of a reference to the thing and a bool, which tells you whether it inserted it or whether it was already there. And then if you want to check whether you inserted this, you have to, check that bool, which is the second one of this pair. And then again, this variable is outside of the scope of the if. And in C++17, you're going to be able to write if and then declare anything you want, semicolon, and then do your comparison or your condition. So that's going to make this code more compact. Actually, I'm not sure I like this that much, because in Juice you can just write map add if not already there, which is doing the same thing without the extra thing. So I think maybe std map is missing something there. I don't know. But now I've sneaked in some C++ 17 stuff. So let's come to the last section of my talk, which is C++ 17, which is the upcoming new C++ standard. Now, so next week I'm going to Kona to the C++ standard committee meeting, and to prepare for this meeting I was just looking at the website of the committee, and they have all the papers and all the proposals there on their website. It's public, and there's like a huge list like this. There's like hundreds of papers. Most of them are quite complicated. It's a very long list, and I was looking at this list and I had a scary realization in this moment. I realized that the C++ language is actually growing and changing faster than I'm learning it, which means that over time my knowledge of C++ is shrinking. And that was a scary thought. So there's a lot of stuff in there that I find really interesting, but then I ask myself, okay, let's just focus on the stuff that I really understand, and then actually, that's, just reading the stuff, or maybe writing a paper on your own is one thing, but then what do you actually use on a daily basis in your code? And then I think we should be a bit more, I'm trying to be a bit more conservative with that. And should I use the cool new feature, whatever, in my code? And of course, there's this question about whether your compiler supports that. But that's another question. But apart from that, I think there's a question whether it helps you write more readable code. And I think the questions here, and by the way, the answers to these questions are going to really depend on what kind of code or what kind of product you're working on. But I think the questions that I'm always asking myself are, does this feature add any information to the reader of the code? Does it reduce redundancy or repetition? Does it reduce the likelihood of errors? Does it replace another less readable feature? Like, for example, one reason I like about lambdas is that lambdas basically killed std bind, which I think is a very unreadable feature, and I'm really happy that you don't really have to use that anymore. And then the most important question is, will everyone in my team understand the code? And I just want to mention two new upcoming features that were voted into the C++ 17 standards, so they're going to be definitely coming. And I'm going to mention them because they tick a lot of those boxes, so I like these features. It's constexpr-if and fold expressions, and they're really useful if you write a lot of template code. Now, this is a silly, simple example, but you can expand this to real-life situations as well. So let's say you want to write a function that's just going to sum up various numbers. And let's say that these numbers have different types, and you want this to be a variadic template function. Now, you can implement this function, for example, like that, right? Where you have a first argument, and you have variadic template pack, and then you're summing them up, and you're doing this recursive template instantiation, right? This is the way you write like a variadic template function like this. Now, this is not going to compile because you need a base case, so you need to terminate this recursive template instantiation. So what you need to do is you need to write a base case. If the parameter pack with a ... if it's empty, like the last time around, then you need to have some other template specialization or like overload that's going to just do nothing. And then there's other things like, will this code actually compile? What do you think? Depends. Who thinks it's going to compile? Okay, why not? Sorry? Well, you have at least one argument. You have arg1. That's going to take care of, like, you're always going to have one argument. No, the reason is, and that's a really horribly complicated thing in the C++ standard. So actually, it's not going to compile, and that's the error you're going to get. Call to function sum that is neither visible in the template definition nor found by argument-dependent lookup. And if you dig for a while, it turns out that there's this horribly complicated section in the standard which basically says if you're having different overloads and different template specializations and the compiler is looking for the one that it should use, it depends on the order in which you write them. So it's only going to compile if you put the base case at the top. So if you do this kind of stuff, you have to worry about these kind of things. And I think you shouldn't be worrying about this because it's a very simple function. And actually this base case is actually completely unnecessary because it's not really doing anything. It's literally doing nothing. So in C++ 17, okay, so what you do want to write is, if you want to get rid of this base case, you want to write something like this, maybe, where you say, okay, the size of ... operator gives you the number of arguments. So that's already there since C++ 11, I think. And you can say, like, to terminate the recursion, instead of having this base case, you can just say, okay, do I have any arguments left? You know, if yes, then keep recursing. Otherwise, just return the only argument. Yeah, so that's the kind of code that you want to write. And the condition is compile time, so there's no problem there. But the problem is, it's again not going to compile. It's going to tell you that, well, if the size of the argument is greater than 0, well, basically what it requires is that even though the if branch, the last time around, size of args is going to be 0, right? So the last time around, it's going to just do return arg1. So the if is completely ignored, and that's compile time. But the problem is that C++ 14 requires the if thing to still be compilable, right? And because you don't have any arguments, some args ... is not going to compile because you need at least one argument. So there is this annoying thing that even if you have an if at compile time, and even if you know that you're not going to take that branch, whatever you have in there still has to be able to compile. And in C++ 17, we're going to get a thing which is called if constexpr, where that's going to be fixed, where you can write if constexpr and then you can write an expression like a compile time condition. And then if that's false, then the code in there is not going, the compiler is not going to try to compile it. And this means that you know, instead of doing these template specializations and extra overloads and base cases, you can write much more local code, which is much closer to like the usual code that you write, like if, else. So it's much more compact and much more readable. It, however, still contains a lot of boilerplate. You know, that's extra first argument, this kind of check. It's not really necessary because you're just adding numbers, right? So the good news is that if the operation that you're doing there is something like plus or multiply or any of the other mathematical operators in C++, there's a new feature as well in C++ 17, which is called fold expressions, where you can just write it like this, and the whole thing just collapses. You can just write args plus ... or times ... or whatever operator you're using, and then the compiler is just going to add all this logic for you, and you don't have to worry about any template recursion or anything. And the best thing about this feature is it's instantly readable. It's obvious what it means. So I think it ticks really a lot of those boxes that I mentioned earlier. And it's really flexible as well. So you can do like a right fold, you can do a left fold, you can specify your own base case if you want to. You know, it's still just, you know, not much code that you have to write. And I think that's a good language feature because it doesn't take much time to explain. So fold expressions is a good feature. I like that. For example, sphere is not such a nice feature. Speaking of which, there's another thing that I'm really looking forward to, which didn't make it into C++ 17, but it made it into a technical specification. It's the concepts TS. And a lot of people are excited about concepts. Probably many of you have heard about this upcoming concepts thing, and I really hope it's going to be in C++ 20. And a lot of people are excited about this because it allows you to do a lot of things. But the reason I'm excited about this is that it's going to get rid of one of the C++ features that I hate the most because I think they're really not readable, which is std enable if. I don't know if who has ever used std enable if here? Yeah. So remember this point class where you have a point and you have x and y coordinates and with the template? Let's say we just want this class to compile if the template argument is a floating point type, like float or double. So the way we do it in C++ 11 or 14 is we have to write it like that. So like to constrain the template. And I can just never remember how to write this down correctly. Like every time I have to use enable if, I have to look it up how to get it right because I think it's just horrible. And you definitely don't want to throw this at your junior developer either. So luckily, when we get concepts in the language, which is unfortunately not going to happen for 17, you can just write it like that, which is really nice. Or there's even a shorter notation where you can write it like this. And then there's another section where you can define the concept of floating point. But you don't have to do it in this kind of horrible extra template argument way. And then the current concept TS says that there's also a third syntax, which is this, which also means the same. And I don't really like this. I think it's not really similar to, how we normally write templates. It's a bit confusing. It has these curly brackets. It reminds me of, these member initializers or like other things. I don't think it's really readable. So I really hope that we're going to get rid of this syntax so that we're going to rework the specification so that this is not going to be there. But let's see what the future brings. But yeah, a lot of stuff that is going to make C++ better, I hope. So, sorry? Even better. I'm almost at the end. To close, let me tell you a little short story. Everybody knows what that is? That's Snake. I love this game. It's great. So a few months ago, we did a really fun thing at Rolly where we got all the developers in the room, and then we told them, hey, we're going to do like a thing where you have 1 hour to implement Snake, whatever way you want. And then everyone went off and started coding, and then they came back, and then we were looking at the different implementations together. And that was a lot of fun. And one thing I realized there was that all the different versions, like most of people actually got it right, and they implemented the whole thing. So we got a lot of great solutions, but they were all very different. And the fun thing about this is that the style in which the code was written reflected the sort of like in many cases reflected the personality of the person who wrote that code. So that was very interesting to see. So that made me realize that every coder has their own style that reflects their personality, and that's absolutely fine. I showed you a little bit about my coding style. I think in the beginning you probably have your own style, which is probably different from mine, which is fine. But I think it's good to be aware of this. So I hope you have a little bit impression of my coding style and what's important for me when I write code, and perhaps it's going to be useful if you write code. So yeah, that's it. Thank you.
Тимур никуда не убегает. Если кто-то хочет задать вопрос, просто помашите мне ручкой, я дам микрофон. Все стесняются при... Есть не стеснительные.
Thank you for the talk. I have a comment more than a question. That was regarding the variable names. That they should be long and descriptive. Especially given that later on you said that most good functions should be short, I would think that if functions are short, it's actually easier to look at short named variables because the scope is short and there's not much, basically to glance at. And especially if those variables are initialized by some function, by call to some method or some function, and a decent IDE will highlight you what the comment for that function was, will basically hint you on, will give you a full-blown documentation snippet about what that function actually returns. It will be, anyhow, it will be much better than any kind of long name you can invent for a given local variable name.
Okay, that's a great comment. Thanks for the comment. Let me say two things about this. First of all, you're absolutely right. I think that there's another thing that I didn't mention is that I think the name should be shorter if the scope is smaller. So, if you have something in the local scope, it's perfectly fine to have a short name. But if something is like in a global header, that's where all these descriptive long names, I think, matter more. And the other comment was, just quickly, that I actually don't think that you should write code that assumes anything about the developer tools that people are using. Because there's always going to be a guy who's still using Vim or Emacs or whatever. So, yeah, I mean, if you work in a really cohesive kind of environment where the whole company uses the exact same setup, okay, fine. Or if you use the same IDE, but again, it really depends on what kind of code you write. Like if you're like us, if you're maintaining like a cross-platform open source framework, you don't assume anything about any people could use any IDE or no IDE, and you would never write code that assumes anything. It should just look good in a text editor, basically, even if we ourselves obviously use, IDEs.
And the other comment I wanted to say, that was regarding how local variables should be padded. Should they be single-spaced or aligned? I believe that in every project, this question needs to be asked and answered just once. And that is exactly when you configure your automatic formatting tool, in which case that's when you decide if you want to use uniformly one way or the other, and then you specify, let's say, a Clang format tool, this language, or whatever is your tool. It probably is configurable. There is some sort of configuration file. You decide it once, you apply it once, and you never need to think about it, and it should never come up in a code review. Like formatting is odd here. Please go and check. This should just never happen. It's actually coming from a excellent talk from 2 years ago, C++Conf, from a guy who's in charge of C++ style in Google, and I kind of fully agree with that.
Again, if you have all those tools, then yeah, definitely. But
Clang format is pretty much everywhere available, I guess.
But then again, there's some version of the file that is going to be in the Git repository, and then it's just helpful to have some kind of conventions about, how this thing that everyone sees if they get your code, how that is going to look like. But yeah, absolutely, you're absolutely right. Thanks for the comment.
So I guess everyone here heard about Hungarian notation. Yes. So okay, maybe you'll just few words.
Yes, actually, when I joined Native Instruments, which was my first coding job, they used to do Hungarian notation, and then they got rid of it. Like the whole company just got rid of it because people realized that if you have a name and you sort of need to, it makes a difference, like it would actually make a difference, you have to know the type to understand the code, then probably your code is not clear enough. And so I don't know, I don't like Hungarian notation. I don't think it's useful.
Okay, so here is an actual question. How would you convince someone not to use Hungarian notation, like on the
Well, I think if you use clear names, then if you have a variable that's called number of something, it's going to be an int. If you have something that's be like a factor, then that's probably going to be a float. If you have something that's called name, that's probably a string. I don't know. If you don't have names that tell you what the function of these things is, and that from that you can't infer the type, then probably Hungarian notation is not your only problem, I guess.
Okay,
I don't know. Like, it's so different. Like if maybe in the particular legacy code base that you work with is written in such a way that Hungarian notation makes sense. Probably, I don't know. Like it's not like none of the stuff that I'm saying are like hard rules that apply to everyone. It's just I found Hungarian notation to be not useful. But yeah, let's discuss it afterwards. I think it could be an interesting discussion.
I have a small question. You had a slide with some prime numbers. Could you show it?
That one.
Yeah, and the question is, you don't have type information about the sequence.
Well, I don't need to. They're integers.
And well, if you add, for example, 2.0 to the end,
it's not going to compile because it's an initializer list.
So it won't compile and won't try to make a sequence of floats and convert everything to them.
Well, okay. So if all the literals are floats, then it's going to compile again. But then you wouldn't use it in a loop like that, right? You wouldn't loop over. Oh, hang on. No, you could do that. But okay, the thing is, if these are floats, then I would make all the literals floats as well. Like I would write 0.0f, 1.0f, blah 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 f, and then everything is a float, and then everything compiles again.
Oh, so it won't compile so it won't implicitly convert int to float.
There's a great rule about these braces. They don't allow narrowing conversions. So whenever you would have a conversion inside one of those initializer lists that would lose some of the precision of the number, like converting a float to an int, the compiler is going to say no.
No, instead of from int to float.
Ooh. I think it wouldn't compile, but let's check it out afterwards. Okay, if there's no more questions, then thanks a lot for listening, and I hope to talk to all of you guys afterwards, and I'm going to practice my Russian as well, so looking forward to that. Thanks.